Okay, we find ourselves at objective 5 now, and suddenly you're learning a new language. You've heard a word, you've been introduced to a word you've never heard before probably, and that is a unit of measurement called the radian. It's just another way of measuring angles. Um, your teacher has probably to some extent explained what a radian is. You may have watched a YouTube video explaining what a radian is, so I'm not going to go into that. I'm going to go into what is usually giving students some trouble at this point in time, and that is the idea that you're going to start seeing fractions. Those fractions are going to revolve around the numbers 1 pi and 2 pi. So let's just go back for a second and let's figure out what 1 pi radian is. Well, it's pretty darn simple. It's halfway around the circle. So if you started right here and you went to right there, I think we can all see that you've traveled 180 degrees. But that's the equivalent of 1 pi radian, this new foreign word that you've just been introduced to, the radian. 1 pi radian is the equivalent of 180 degrees. Now, what about the other one, 2 pi radian? Well, if it takes 1 pi radian to go halfway around, then it would take 2 pi radian to go all the way around. So that sets up the equivalency of 360 degrees equals 2 pi radians. Now, like I said, the only thing is you're not going to see 1 pi and 2 pi very often. It's going to be mostly in fraction form. So we just have to review a few fractions. What would be the equivalent of 1 pi radian if it was divided into sevenths? Well, don't make the problem any harder than it really is. All it would be 7 pi over 7. What if it was divided up into 19ths? Then it would be 19 pi over 19. You get the idea. 13 pi over 13. And what if it was divided up into 22s? It would be 22 pi over 22. Each one of these 4 fractions is equivalent to 1 pi. So each one of these fractions is telling you you have gone 180 degrees. You've gone halfway around the circle. Now, what about going all the way around the circle? Well, that would be 2 pi. So if we were using 11ths as our denominator, then the numerator would be 22 pi over 11. If we were using 8ths as our denominator, 16 pi over 8. 15 would be 30 pi over 15. And 18 would be 36 pi over 18. All 4 of these fractions are equivalent to 2 pi, and all 4 of these fractions are equivalent to 360 degrees. Okay, let's do a few examples that would take you through problem 18 on the worksheet. Example 1 says, what if you had an angle of theta equals 7 pi over 9? Where would that be? Let's draw the terminating ray. Where would the reference angle be? What quadrant would it be in? So 7 pi over 9. And obviously, this question is written in ninths. So that's the key to the whole problem. It's written in ninths. So 9 pi over 9 would be right here. Well, we didn't make it to 9 pi over 9. We only made it to 7 pi over 9. So we know we did not make it to this position right here. We fell short. So here it is, right here. There's our terminating ray. So we know we're in quadrant 2. But what would the reference angle be? Well, we'd be at 9 pi right here, but we didn't make it. How far did we fall short? We fell short by 2 pi over 9. 2 pi over 9. Now, mathematically, how do we get that? Well, take what I just said and turn it into math. We didn't get all the way to 9 pi over 9. But we did get to 7 pi over 9. And that's how the reference angle is 2 pi over 9 right there. Because remember, the reference angle is always from the horizontal. Now, how about example number 2? 21 pi over 10. The key to the problem is it's written in tenths. So, getting halfway around 180 degrees would be the equivalent of 10 pi over 10. Getting all the way around back 360 degrees would be 20 pi over 10. And then we even went a little bit more after that. So what we did was we went all the way around and then we made it a little bit past 20 pi over 10 to get to 21 pi over 10. So there I am. I'm in quadrant 1 and my reference angle is 1 pi over 10. Example number 3. What if theta equaled negative 16 pi over 7? Okay. The key is we're in sevenths, and it's negative, so we're going the other way. So negative 7 pi over 7 would be right there if we went this way. Now, we're going to make it all the way around, because we're going to get to 14 pi over 7. But then we're going to go a little bit more. We're going to go 2 pi over 7 more. And that's where we're going to end up. So that's my terminating ray right there. It's in quadrant 4. And the reference angle, I'd be at 7 pi over 7. Remember, the negative just means I'm going this way. So I'd be at 7 pi over 7. Then I'd be at 14 pi over 7. And then 2 more would get me to 16 pi over 7. So my reference angle is 2 pi over 7. Okay, now we're going to do something we did when we were working with degrees, but now we're going to just do it with radians. We're going to find positive and negative coterminal angles. Now, the key was, when I was in degrees, a positive coterminal angle just meant wherever you are, go around a complete circle. So add 360 degrees. And then a negative coterminal angle was wherever you are, go 360 degrees the other way. So subtract 360 degrees. Well, now that we're in radians, you still have an equivalency. 360 degrees is the equivalent of 2 pi radians. So really all you're doing to find the positive coterminal, you're adding 2 pi radians. And to find the negative, you're subtracting 2 pi radians. However, like I said a couple minutes before, you're never going to see these nice whole numbers. It's always dependent on whatever the denominator of the fraction is. So I'm just going to do one example. What if theta was at 16 pi over 9? Well, let's first of all just figure out where would we be at 16 pi over 9. The 9 is the key to the whole problem. So 9 pi over 9 would get us right there. And then 18 pi over 9 would get us all the way around back to where we started. But we didn't get all the way around back to where we started. We only got to 16 pi over 9. So that would put us in quadrant 4 right here. Okay, so this would be 16 pi over 9 right there. Now, what would be a positive coterminal? So if I went 360 degrees around in the positive direction, is the equivalent of adding 2 pi. So 16 pi over 9 plus 2 pi. But I can't do that because remember, when we're adding fractions, we need common denominators. So that's actually 16 pi over 9 plus. Now the equivalency of 2 pi, when it's written in terms of ninths, would be 18 pi over 9. Now I can add them because I have common denominators. So this would be 34 pi over 9. So that would be your positive coterminal angle. Now let's see if by going the other way, we're going to get a negative. So that would be 16 pi over 9 minus 2 pi. But for the exact same reason, we need common denominators. So that would be 16 pi over 9 minus 18 pi over 9, which is negative 2 pi over 9. So there's your positive coterminal, and there's your negative coterminal.